Today we're going to do a case 3 example, and then we're going to try just a mixture of word problems and try to identify those. I think you'll see why this is a case 3. It says biologists have found that the number of chirps crickets make is related to temperature. Relationship is very close to being a linear equation. That means, like, if you were to do an experiment with chirps and temperature, and you plotted the points, it would look like a line. When crickets chirp 124 times, it's about 68 degrees Fahrenheit. And when they chirp 172 times, it's about 80 degrees Fahrenheit. So part A says write a linear equation to model cricket chirp based on temperature. So the first thing that I would do is, of course, find my letters. So we have number of. So it looks like we're talking about chirps and temperature. Temperature is definitely independent. You cannot control temperature, so that is your X. And then your Y, of course, is how many times the crickets will chirp based on the degrees outside it is. So the reason I know right away that this is a case 3 is because I see 4 numbers. I see 124, I see 68, I see 172, and 80. So chances are there's 4 numbers, there's 2 ordered pairs, it's a case 3. The first thing I would do is I would pair up my temperature with my chirps. So my first temperature is 68, and my chirps is 124. My second temperature is 80, and the chirps are more frequent, 172. So since this is 2 ordered pairs, I would know, okay, it's a case 3. I will have 2 formulas. I have to do y2 minus y1 over x2 minus x1 first. 172 minus 124 is 48. 80 minus 60 is 12. And conveniently, 48 over 12 is 4. So there's my first part of my case 3 setup. And then my second part is, of course, to use the point slope formula. 4 is your slope. That has to go in the middle. And you can pick if you want to use the first order pair or the second. Let's say we go with the second. So 172 goes in the first slot and 80 goes in the last. The good news is once you get to this part, the rest is math. So go ahead and distribute and solve that very quickly. So when you distribute, you get 320. When you add 172, you get 4x minus 148. So there's your linear equation. That's what you're going to use to answer the follow-ups. It says how many times would a cricket chirp if it was 50 degrees outside? So right here, 50 degrees, well, temperature is x. So I gave you an x value. So we're going to leave y in the problem, but we're going to change x into 50. So if we do 4 times 50, that's 200. 200 minus 148, I believe, is 52. And we are talking about chirp per minute. So cricket will chirp about 52 times each minute if it is 50 degrees outside. Letter C says, at what temperature? So right there, at what temperature, that's code for find x, since temperature is x. That means I must give you the y value. What temperature would the model predict no chirping? Well, no chirping means 0 chirps. So you're using 0 for y. So we're going to do 0 equals 4x minus 148. So if we were to add 148 and divide by 4, we are going to get 37 degrees. So at 37 degrees, they're going to stop chirping. This next example is going to be the last example just for this lesson video, and then we'll finish the last problems in the next video. So this does not say what case it is, so we're going to read it and try to figure it out. The cost for riding 10 miles in a taxi is $12.50. The cost for riding 24 miles is $23. All right, so nowhere in there did it say what the initial fee was. It doesn't say what the cost is for just 1 mile. It doesn't say per mile. So the other hint is I see 4 numbers in here. I see 10 and 12.50. I see 24 and 23. So what I want to do is I want to make sure that I define my variables like it says. So I have x is number of, y is number of. So it looks like we're talking about dollars and miles. So miles will be X because money is always Y. Oops, number of dollars. So then it says write a linear equation. It says this other stuff models the cost C after writing M miles. That just means they want you to change your Y into C. So Y is dollars, well, cost is dollars. So what I like to do is do all my math and then I'll change the variables out at the very end. That's usually easiest for me. So I want you to go through, right? Your ordered pairs would be 10 miles and $12.50. And then you have 24 miles, go with $23. So what I want you to do is I want you to go through the two formulas for a case 3 problem and then see what you get when we come back. So the first thing you want to make sure is that you did your slope right. So you get 10.5 over 14, which is 75 cents basically. So then part 2 is I use the second order pair. So you want to substitute, distribute, and then add. You should get 0.75x plus 5. The only thing is that makes this a little different is they want you to change the variables into C for cost and M per mile. That's the only difference. So once you're done, just change out the variables and you got it. So now you have a formula. You can answer part D. It says, what's the cost of riding 50 miles? All right, so 50 miles, that would be your X, or in this case, M. So you're using that for M. So we're going to do 0.75 times 50 plus 5. So it looks like your cost is going to be, when you work that out, $42.50.